Alright folks, today we're going to be checking out some problems from the FMA physics exam. Let's go ahead, check them out. Over here, we have a VT graph of some kind of an object, a toy car moving along in a straight line. We want to know the maximum displacement from start for the toy car. So here's my graph, and I want to know the maximum displacement if this is a VT graph. So what can I do? When will the maximum displacement happen? Well, it'll probably happen before, he's traveling in a straight line, right? So there's only two ways he can go, left or right. So when he's has a positive slope for his velocity, when his velocity is positive, that means he's going in the forward direction. When his velocity is negative, he's going backwards. So his maximum displacement from the start should be right before he starts going backwards. So let's just go ahead and calculate the area under this curve until he starts going backwards, and that'll give us his maximum displacement from the start. So let's do that. What info do we have? Well, he starts going backwards at this time, which looks like 2.5. And this over here, this max velocity is 4 meters per second. And do we know anything else? Doesn't seem like it. Oh, and this over here, this point when he starts going at a faster velocity, or when he starts cruising, like at a constant velocity, is 1. T equals 1 second. Is that right? Yep. So let's find this area. As you hopefully recall, the area of this thing is going to be what? First, let me take the area of this kind of trapezoidal figure. So I'm going to have this thing's area be the average of the bases times the height. So the base is 1.5. And what is this over here? This over here looks to be 1.5. So let me go ahead and write that nicely for you. So if we want to find the displacement covered in this area of the graph, we'll have to do the average of the bases, which is going to be 2.5 minus 1 plus, don't forget about the top base, which is going to be just 0.5. Alright, and times the height, which is 4. That's going to be half of 2.5 minus 1 is 1.5, plus 0.5 is 2. That goes to 1, and this is 4. So that tells us the displacement here is 4. And how about in this little trapezoid? Well, in that trapezoidal area, we've got this base is 4, and this base is how much? 2. So we've got half, sorry, I might have to zoom out as a matter of fact. We've got half of 2 plus 4 times my height of 1. That's going to give me, sorry if you don't see that, that's going to give me 3, right? So that means my area right here is 3. And so the biggest displacement, his maximum displacement from the starting position is 7 meters. 7 meters. Hopefully you can see that. And that's going to be answer choice D. Alright, nice problem. I liked it. Let's move on to the next one, number 5.
Ambition plus MKO plus scaffolding equal learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.